So here is the circuit for the sound detector board. So first over here we have an RGB LED, and this is just connected to pins 9, 6, and 5, and then brought to ground right here. So here we have the sound detector board, and it is, first you have the VCC, which just detects sound or no sound, so basically on or off. And when sound is on and the board is plugged in, this LED here will turn on. And this function here, envelope, will scale how loud a sound is, and that's what we're using the RGB for, is to measure how loud something is. So if you look here for the LED, if I hit the table, the LED will turn on, which means sound is registered. So now the light is going to change based on the intensity of the music. So if I play music up close to the sound receptor here, the light will change colors.
The city was ruthless, the city was cruel. They had one thing in common, they were good and bad. She'd say, faster, faster, the lights are turning red. Life in the fast lane surely makes you lose your mind.
Code for the basic soundboard. So first we're setting up the variables. So for the RGB, we're saying the red, the pin, the green pin, and the blue pin are in pins 5, 6, and 9. And then the sound pin from the soundboard is in analog pin 0. So now you're creating variables for storing this is the raw sound, and then this is the scaled sound. And here you are doing the serial begin, so you can serial print the values. And then you're setting the RGB pins to output. Here you're saying that sound is equal to the analog reading of the sound pin, and then you're scaling it. So each of these values is a starting point, an extremely loud point, and then the number of cases that are to be used. So here you have the serial print, it'll print the sound, quotes, and then the scaled sound. So now you're switching the case from the original sound to the scaled value. So now when the case equals 0, the RGB will be blue, and that is with the red pin on low, the green pin on low, and the blue pin on high, and a delay of 500 milliseconds. If the case equals 1, then the RGB will be equal to green, and that means that the green pin will be on high, and the red, the blue will be on low, and then you have a delay. If case equals 2, then the RGB will be on yellow, which means that the red and green are on high, the blue is on low, and there's a delay of 500 milliseconds. If the case equals 3, then the RGB will be equal to red, so the red pin will be on high and the other two will be on low. There'll be a delay of 500 milliseconds, and so then the default is off, so if there's no sound being recorded, then all 3 will be on low. So now if you open the serial monitor, right now there's not that much sound, so it's registering as 0, but if you play music, then the numbers will begin to change. So here is my modification to the soundboard. So I added 4 LEDs, and what is going to happen is when the sound plays like along to music, it'll resemble like a light show. So when this RGB displays blue, the blue will mirror that. When it displays green, the green will mirror that. And so when the sound changes with a song, it'll play along to that. And so I just connected that with 100 ohm resistors in pins 13, 12, 11, and 8, and then they're all grounded in the negative terminal here, which is brought over to the negative terminal here, which is grounded on the board. So now once music is played, you can watch the light change to the music.
You get off and it was life in the fast lane, surely makes you lose your mind. Life in the fast lane, life in the fast lane, every day, all the time. Life in the fast lane.
In order to modify this, I added the 4 LEDs as constant integers and labeled the pins that they were in, and then I set all 4 of them to output, And then I just mirrored the code of the RGB. So for the blue, I turned the blue LED on high, the rest on low. For the green was on high and the rest were on low. The yellow was on high and the rest were on low. The red was on high and the rest were on low, and the default, they were all turned to low.